The fastest processor on Earth has a secret. Most of the time, it is waiting for its next meal. Here is the number nobody puts on the box. A modern AI processor can do arithmetic far faster than data can arrive from its memory, which means the question that decides real performance is not how fast the chip can think. It is how fast you can feed it. Starve it, and the most expensive silicon ever sold sits idle, burning power, earning nothing. This is Under the Hood, the technology the world actually runs on, one layer at a time. Today, the feeding problem, and how the most boring part in the computer became the hardest thing on Earth to buy. The problem has a name, and it is older than the AI boom. Engineers call it the memory wall. For 30 years, processors gained speed at a pace memory never matched. Every generation, the gap widened a little more. Nobody minded much, because most software asks a chip to think hard about a little data. Then artificial intelligence arrived and reversed it. A modern model is a mountain of numbers that must flow through the processor over and over just to produce a sentence. Suddenly, the wall was not an engineering footnote. It was the bill. So how do you feed a chip that eats mountains? 3 moves, each one physical. First, stop laying memory flat and stack it. 8, 12 stories of silicon, one die on another. Second, connect the stories by drilling thousands of microscopic shafts straight down through the stack, so the tower behaves like one building with one lift system. Third, move the whole tower next door to the processor, millimeters away, on the same slab, and run thousands of wires between them, where an ordinary computer runs a few hundred. Stacked, drilled, moved next door. That is high-bandwidth memory. Now, why can only 3 companies on the planet do this well? Because stacking multiplies failure. Build 1 story, and a flaw costs you 1 die. Build 12, and a single flaw, 1 story out of true, 1 shaft misaligned, can write off the whole tower. So every die is tested before it is stacked. Every stack is tested again, and the customer spends months qualifying the result before a single order ships. This is memory that has stopped being a commodity and started being a craft. And here is where the economics turn upside down. Ordinary memory was the textbook commodity. Every maker's chips interchangeable, prices collapsing in every glut, profits appearing and vanishing with the cycle. The stacked kind behaves like the opposite. It is qualified customer by customer, so a buyer cannot swap one maker for another on a whim. It is sold out quarters ahead. And buyers now pay in advance to reserve supply that does not yet exist. Same silicon, same industry, completely different business. There's a photograph from 1898 that explains this position better than any spreadsheet. Gold rush prospectors, single file, climbing the Chilkoot Pass. Because to reach the gold fields, every one of them had to climb the same narrow staircase of ice. The gold was uncertain. The queue was not. Whoever stands where the queue forms does not need the gold to pay off. They get paid on the way through, by every miner, win or lose. In this boom, the stacked memory beside the processor is the narrow pass. The models may or may not strike gold. The queue pays regardless. Because this is a position, not a law of nature, say plainly how it could end. 3 ways historically. Designers shrink the meal. Smaller models, cleverer arithmetic that moves less data per thought. Rivals close the gap, because a queue this profitable recruits its own competition. Or the bottleneck simply moves, to power, to cooling, to something nobody is watching yet, and yesterday's choke point becomes ordinary plumbing. The constraint always moves eventually. The skill is noticing when. So here is the part you can carry far away from silicon. In any boom, ignore the product on the poster and ask one question instead. Where is the queue? Find the input everyone must wait for, the thing sold out while everything else sits on the shelf. That is where the pricing power has quietly pooled. The chips get the headlines. The thing the chips wait for gets the profits. Next in Under the Hood, the electricity. The chips are no longer the hard part. Finding the power to run them is.